Hello, everybody. We are back for the conferences of this afternoon. Sorry, we had a technical problem. It is a pleasure for me now to present you to Sian Davies, who is the lead instructor of the International Tech School FemHack. With an MA in Intelligence and International Security at King's College London, she has worked in some well-known companies such as Deloitte. Sian's expertise in analytics has promoted her to becoming a technical lead in the Open University in Oxford College of Marketing and finally in FemHack, where she teaches data engineering and science. Hello, Sian. Good afternoon. How are you? It's up to you right now. You can start talking whatever you want.
Thanks so much. Hi, everyone. I am going to share my screen because I have a little presentation. So looking forward to talking to you all. And yeah, let me get my screen up right now. So you should be able to see my screen.
I confirm. Everything's good.
Perfect. Thank you so much. All right. Yeah. So the topic I've chosen for today, I hope it's interesting to a lot of you. Maybe you're already thinking about data science, what that means to you, and maybe you're already working with data science, and sometimes you're finding it difficult to explain to other people. So I had this idea that I would use something from my classroom, which I find very helpful to explain data science, and that is data visualization, or really images and pictures. So that's what I'm going to talk about today. Thanks already for the introduction. A little bit more about me. I'm a kind of self-confessed data visualization geek. I'm really passionate about helping people tell their data stories, and I like to see people making data-driven decisions. I've worked in this industry since 2010. I spent about 5 years of that doing solution consulting, business intelligence consulting, and I've been teaching and training for about 4 years now. I've actually been at FemHack since September 2021, so my whole FemHack experience has been against the backdrop of the pandemic. I have managed to teach some classes in person. I'm currently teaching in a classroom, I'm very happy to say, in person in Barcelona, but I've also taught a lot of this course online as well. The course, so far I've graduated 91 students to prepare them for going into the industry. This is an intensive course. It's a 9-week course and it's for career changers. So for adults who want to take on a career in data science, data analytics, data engineering, and I want to specifically focus on data science today. We take 7 data science case studies during the course, and typically about half of my students will also apply data science to their final projects. I should point out that none of the students that come to me are very familiar with machine learning beforehand. Some people have no knowledge at all, and most of them, if they've read something, that's about it. So they're all new, and we're teaching them quite a lot of stuff over that 9 weeks, actually. I thought I would pick out some of the profiles of my students. So I've got a couple here. The first one that I have that I've picked out is Anna. She's from Barcelona. Her background is in engineering and business development, and I taught her in the summer of this year. This is Olabumni. She's from Nigeria. Her background's in marketing and business strategy, and I taught her online, but in Berlin. I didn't manage to meet her until after the course. We were in Berlin in March of this year. And finally, this is Marta. She lives just outside Barcelona, actually. She was in the same course as Anna, but I picked her out because she has quite a different background, not really, I would say, very corporate at all. So that's a little bit about my students. I've just dropped my pen, so give me a second. These things happen. So my students, they come to me with different backgrounds from business, or maybe different expertise and skills. And what they're here to learn about is how to work in data. So what do they learn in my class? Well, as I mentioned, it's a 9-week intensive class. That's the full day. So they're in the classroom from 9 until 6 every day. It's quite a lot. It's a full-time job. We teach them how to use Python to manipulate data. We teach them how to use Tableau for data visualization. Really important, really useful, very hireable skill set, data visualization. We teach them SQL through MySQL, so the open source version. That's for data management, data engineering, database design. And we teach them also machine learning, specifically supervised and unsupervised learning from sklearn and Keras. So either in Google Colab or in a Python environment such as Jupyter Notebook. And what they learn overall is how to run a project end to end, a data analysis project from the collection point, collecting data, to that insight and those recommendations at the end of it. So we cram a lot into 9 weeks. I hope you're already starting to see that. And some of that is definitely data science. So in terms of my topic here today, what I want to get you thinking about is if I asked you to draw a picture that explains what data is or explains data as a concept, I wonder what that would look like to you. So let's pretend you have a pen, you have some paper, and you just have to draw that diagram. Some of you might be thinking, I'm going to draw a box or maybe a cylinder. Some people might be thinking, I'm going to draw a diagram with some arrows. Maybe some of you might be thinking, I can draw a brain, a human brain, or a computer or a phone, because that's probably how you interact with data most often. Some people may be thinking ahead, maybe I'll draw a graph, because that's a good explanation, a graph or a chart, maybe a line chart. Everyone likes to draw a line chart. Maybe some people think, I'm just going to draw a really heavy textbook, because I kind of know what's involved in data science or data visualization or data analysis, and it's a lot of learning. So that's the kind of thing that you might be drawing. And what's interesting about that is that when I started drawing pictures or diagrams to explain data processes, that's what they look like, actually. Very simple. This was the ones that I would have drawn in 2010 when I first started working in databases, first started understanding data flows through an organization, getting data from information point through a database and to the reports. They looked pretty simple, just a series of shapes. Over time, things have got a little bit more complicated. So the type of diagram that I'm rolling out now to my students, there's a few more steps involved. We might be talking about supervised and unsupervised learning or neural networks and deep learning, or maybe just an end-to-end machine learning modeling process from inception to production. But the thing is that we're all more comfortable using pictures now than we are using text, I imagine. We're all active internet users. We're all using our mobile phones, our smartphones all the time, and we're really used to visual engagement. Now, why do we use pictures to explain things? Well, 90% of the information transmitted to your brain is actually going to be visual. So 90% of the information you take in is images anyway. And it's quick. Processing an image just takes 13 milliseconds. Reading a body of text to explain the same thing is going to take an awful lot longer. The human brain can process images 60,000 times faster than it can process text. And those are just the headlines. You've been learning how to interpret images since you could first open your eyes. Before you could even really see and make out shapes, you were learning what images were. And you're relying on the evolution of thousands of years of history of people learning what images are. So that's why images are so important. And the other thing is that they're shared. I teach a class full of multiple languages and multiple cultures, people at different areas of their different stages of their life, different levels of experience, different levels of business and cultural awareness. And maybe they don't understand me that well because we're all speaking a different language, but images are shared. Everyone can understand the same image. So try a thought experiment here. Imagine if I'd set you these challenges. I need you to communicate where your house is to a delivery driver. You've ordered a delivery driver to bring you some food, maybe takeaway from one of those companies that I won't mention. And I need you to do that without access to Google Maps. So you can't just give them a postcode. You actually need to say it, how to get there, how to get there. You're probably going to process that in set of instructions through a series of images. It might be like go along the street, wait until you see the big hedge on the left, or the big red building, or just after this shop, then you turn, that kind of thing. Imagine then that you had to teach somebody to make a bed, and you had to do this verbally. So you have to teach somebody how to put a bed together, to put the sheets on, to put the pillows on, to fill the duvet cover, and to lay it all up really nicely. Even I'm doing it now without hand gestures. I'm going to do this and make squares 100 times, even if I'm trying to do it verbally. And what about trying to promote your brand or your next event, but only using text? You're only allowed to use text and words. I think it would be really hard. And we can see the logos, for example, the images for this event, for the FemHack event. Lots of color, lots of imagery, everything that sticks to the event, that makes us remember it, makes us recognize it. Images are super important to us. And part of the reason that I use images in the classroom is this is just not the kind of teacher that I want to be. I don't want to be a teacher who's, I'm sure this guy is a great teacher, old school with the blackboard there, lots of complex formulas. That's just not the way that I find easy to communicate myself. And I don't feel that it works that well for a mixed student set. So different backgrounds, as I mentioned, different cultures. So the types of pictures that I use in my class to explain data science and to explain scientific principles, to explain data engineering and data analysis, these are the types of pictures. I definitely use memes. I do like to use memes. It's always funny, it always helps, and it cheers us all up. I like to use illustrations, graphics, and videos in my presentations, maybe when I'm talking. I bring up useful kind of aid memoirs to help me explain certain concepts. I would also use simplified graphs, and I'll show you a couple of examples soon. So something that's a simplified version of the whole concept, the graph, the chart, and the map. And the other thing is I would use real data visualizations. And I actually encourage the students to spend time on those data visualizations themselves to understand not just data science, but to really understand data. So some examples, a few memes to start us off. Most of the memes we use in class do seem to feature cats. I don't know why that is. I'll leave you to decide that for yourselves. It normally means that cat's doing something funny and there's some sort of statistical or scientific principle that can communicate. I particularly like this one. It gets across the feeling about correlation not being causation. This cat here sat on this beautiful, slightly busted roof. We always have a data memes channel in our class Slack workspace, actually. So the students and myself can always post memes that we find that are relevant to our experience. Other types of memes that we might use, sometimes I use memes as shortcuts to just explain something that's a little bit technical, maybe takes a bit of time to talk through, to work through in the classroom, something that would take a bit of communication, a lot of examples. I find that this meme is a great way to explain overfitting. If you've not run into that concept before, it's a data science concept where you've effectively taught the machine really, really well to fit the data that you're training it on. So to fit your training data set, but you haven't taught the machine to be flexible for your real data set. So this example, this visual here really nicely shows that. So this bed is perfectly fitted to somebody sleeping in that exact position, but wouldn't adapt to anything else. And sometimes we use memes just to share and empathize about frustration. It's one of my favorites because I have been in this situation, I would say minimum 50 times since I started working in the data industry, where I've either had code that doesn't work and I don't know why, or I've had code that does work and I don't know why either. So I think it's a pretty good illustration of how I have felt in the past when I've been consulting, how I still feel sometimes in class. I'm a pretty terrible speller, so when I'm live coding and the students are coding along, there's often a bracket missing or a colon or something in the wrong place, and how my students often feel when they're working through their projects. And I think this is very normal. We can all relate to this. So we use this kind of meme to make us feel a little bit better, and to join us all together. So that's for memes. I'll try to have some slightly more serious stuff now. So what I want to try to do as well is demystify. It's really my main task as a teacher. I think anything around the data space, people have the impression that it's very complex, that they couldn't understand it, that these are tools that are outside of their reach, that they're just not they're not engaged enough, they're not intelligent enough, or they're not trained enough to be able to use this technology. And that's nothing that I feel is true. I don't feel that your background or what you've done before should really stop you being able to engage with the technological revolution in front of you. And all of these tools actually should be accessible. So I try to demystify them. I try to take the noise away and just leave the science that we actually need. So we do need some science, but some people are really not comfortable with science when they come into my classroom. Maybe they never really liked maths. Maybe they had a terrible teacher. Maybe some of you had a terrible teacher for maths. I know that I had at least one bad teacher for maths. Maybe statistics always felt really boring or inaccessible, and maybe they don't really understand scientific techniques either, the experimentation, having a robust review process, statistical inference to make sure that you haven't gone off the rails, being aware of your own bias, all of those things. So how do we handle that in the classroom? Or how do you, in a different situation, how could you handle that in a team where you're trying to use data to make decisions? So in this case, I would recommend using pictures to help to bridge the gap between what people know already and what the new concepts and methods are. So a couple of examples. I always start with, every time I'm talking about statistics, I always start with Kermit the Frog because I feel that it lightens the mood before we get any further. People do get a bit worried when I say it's the statistics class, so try to lighten the mood on that one. Okay, so what about explaining regression models? Now, if you're not that familiar with data science, maybe you've learned something actually during this conference. You might have been introduced to some of these models already. Maybe you're not too sure yourself, but let's just say that you might have heard of this concept of hello world when you're building applications or when you're starting to work with computer models for the first time. Linear regression is pretty much the hello world of machine learning. It's the first data science model that we meet in my class, and it's generally the first one you'll see in the textbooks as well. So if you open a data science textbook, probably linear regression is at the top. One of the reasons is it's very easy to understand. And the way that we would explain that in class is I would talk about this in the world of a scatter plot. Scatter plots, which I think pretty much everybody's familiar with and has no problem understanding, rely on two things: an x-axis and a y-axis. And the points, the data points, are just at the intersect between those two values. What we talk about for the x-axis is the independent variable. The y-axis is the dependent variable. So turn that into a sentence. What I would say is, as x goes up, so does y. Or if we were looking at inverse correlation or reverse correlation, negative correlation, I would say, as x goes up, y goes down. But in this case, we are talking about a positive correlation. So as x goes up, y also goes up. Now, most people can understand a scatter plot. Most people are familiar with that. In fact, scatter plots are using one of the key pre-attentive visual attributes that your brain processes super fast. It looks at the relative position of those points, and you can interpret a trend. Even if I don't have this line of regression in there, you can probably see, pretend that line's not there for a second, you can see that those points are all kind of tuning in one line, in one general direction. So I don't really need to explain what a scatter plot is to my students. It's intuitive, it's familiar, and that really helps. To use a scatter plot to explain machine learning with linear regression, all I need to say is, instead of 1x, for example, the number of hours that Sian spends in the sun, the more sunburnt she gets. I'm really worried about the Spanish summer coming my way. So instead of just one variable down here, we have a lot of variables, and we combine them together to try to predict the y. So now we take all of our independent variables, we combine them to try to predict the y, and that gives us a linear positive correlation relationship. And with linear regression, what we're doing is building a model and teaching it to recognize that pattern. So we're building a model that looks for the independent variables and understands if the number is 15 here, then the number will be 25 or 100 or whatever it is on the y-axis. So it really helps me explaining linear regression by using this simple scatter plot approach. And I'll find myself, when I'm running those lessons, every time I'm explaining a linear regression, I'll find myself drawing scatter plots. And you can actually get more complicated by using the same method, the same model. We can, of course, use examples to explain what X and Y can be. But once we draw that trend line or that regression line in, we can start talking about other concepts, for example, the error term, the residual, the ordinary least squares, the least squares measurement, the total squares difference, all of those things, the intercept, the R squared value, the p-value, etc. So we use this baseline, this visual, once we get to a point that the students understand, yes, this is familiar, I already know what this part means, then we just layer on top of that other concepts. Another thing that I will do when I use images in my class is I use the images that might recall some kind of familiar context. So the previous example, we looked at something that was intuitive and familiar in the sense of a data visualization or a chart or a graph. Here I've just got an image, kind of cartoonish, that I found on the internet. And it's teaching us about association. But it's teaching us about association not in a scientific way, not with a mathematical formula, really heavy formula or anything like that, but actually teaching us about association from the perspective of me being a customer. So I encourage students to start thinking, when you go to a shop, you buy this, and what else do you buy when you're there? So that teaches us what association is. And that can be something that's maybe a little bit harder to get your head around without thinking about that shopping example. Shopping is, I think, a really good example because everybody is a shopper. Everybody has to be a consumer. You have to go to the shop and buy food at some point, even if you're lucky enough to get someone to buy it for you. So that really helps for association. Similarly, clustering. Remember the last time that you sorted out all the potatoes into different colors? Okay, maybe you didn't have to do that, but we've all bought potatoes at some point. We've all seen potatoes in the supermarket, and you've seen that they're different colors and they're stocked in different places. Well, this is another good way of just setting that familiar context. So maybe people start thinking about, oh yeah, so we have the same thing, but it's different types or different attributes of it. In this case, the attribute would just be the type or the color or the particular seed. And we can use that to cluster, to group the potatoes into their different varieties. So another familiar context through images. Sometimes I use images to also remind people not just of the context of what we're doing scientifically, but their own context as being a data provider. It's very easy when you're learning data science to think of it as something that's happening to other people and to sort of forget that you are also part of all these scientific experiments. A/B testing is a concept that students might have heard about, but maybe they don't really think about it as being a statistical technique. And secondly, they might not think about it as something that they have been subject to. So we talk about A/B testing in terms of mobile apps because almost all of my students have a smartphone. Almost all of them use apps all the time. And we talk about, has there been an instance where you've seen a new version of your app and maybe you wondered why your friend had the same app, but it looks slightly different. And that gets us to talking about what it means to do an A/B test and what the statistical basis behind that test is. And in this case, what it's saying is we can test two versions of the same app side by side and figure out which one has the best attendance or engagement or something like that. So that's a way of introducing a statistical method in a way, in a familiar context to the students. And finally, also reminding the students that they are the data. So not just that they produce the data, but they also are the data. Once you start learning about facial recognition, that it's machine learning as a process that's based on machine learning technology, then you start to think about, where do the training images come from for facial recognition systems? And once you think about that, then you start to you get some empathy. You put yourself in the place and you think, oh, yes, I am the data. So 3 examples. I'm either the customer, I've either done something before, or I actually am the data in myself, in and of myself. Now, the other category of imagery and pictures that I did want to talk about, data visualization. I come from a background of data visualization. Before I was teaching this course, I spent a lot of time working with a couple of different BI tools, SAP, SAP Business Intelligence, Tableau, and Power BI. So I also did a little bit of work with ClickView back in the day too. Now, knowing data visualization as I do and knowing how many businesses rely on data visualization, I know that it's an important part of every data project. So I try to persuade the students that they need to spend real time, invest a lot of time, every data set that they work with to understand that data using visualization. especially when you have a super quick tool. Tableau is a very quick, very intuitive tool. You can drag and drop, you can get it wrong, you can do ad hoc analysis, you can click and make the filters interactive. So you can really explore the data in a very quick space of time. Doesn't matter what the output looks like at the end, as long as you've spent that time understanding the data. What you're looking for is trends, patterns, relationships. And once you understand the data, then you have a good chance of applying data science. If you don't understand your data, if you're not a subject matter expert of your data, then any model that you apply will ultimately be worthless. You won't be able to get to any useful insight of the data. So what I try to get my students to do is, well, I set them a number of challenges. In the second week of our course, we get them working with different data sets. And when we come to the middle of our course, we do a mid-bootcamp project where part of that is actually visualizing the data. They visualize the data before they apply the data science component of the project. And I've pulled out a couple of examples here from one of my recent courses. And this is a real estate project. It's a regression project. If you don't know what that is, it's where we use data science models, in this case, simple linear regression or KNN or Kmeans, KNN, to predict the price of a price of a house. And if any of you have ever bought a house, you'll know that the prices are very up and down, very turbulent. Depends on a lot of features. And sometimes you'll even look at a house and think, well, why is it that price? Or maybe you're trying to work out how much your own house is worth. And sometimes just little things like the lighting or different way of decorating it can make a big difference. So house prices are very subjective. It's quite hard to get an accurate model for predicting the house price. And a lot of features, potentially hundreds of features, are involved in that. So what we do is we give the students quite a big data set, lots of different features. One of the features is location, so around zip code. We also have the square foot of the living area, as we can see up here, the square foot of the basement, the square foot above the basement, and the total square footage. And we give them this information along with the actual price, so we get them to start exploring and looking for patterns in the data. And what Simon, one of the students, did here was do a really nice job of visualizing it in a map so that we could see all of those different elements in terms of high price, in this case in red to orange, and then the lower prices. So understanding this data geographically allows you to work out where, I mean, you can sort of already see some of the visual clusters around the high pricing and some exceptions. And if you don't know that much about the area around, this is based in Seattle, King County, Seattle, then it can be very helpful to explore the data before you go any further. If you made an assumption, for example, that everything in this area was going to be high priced and everything in this area was going to be low priced. Well, what about the exceptions down here? So just understanding that data geographically can be really helpful. And we can see as well clustering in the other charts in terms of the price versus other features. And some slightly maybe more unusual patterns you can see down there. So that's the price versus the total plot size or the total square footage of the property. Same data set, different student. This was worked on by Andrew, who did this for me in October, actually last year, over a year ago now, October 2020, who was in one of my first classes. And he spent a lot of time investigating this data, looking particularly for patterns, trends. We've got here price versus square foot above again, price versus square foot, and price versus the whole square foot of the lot. And he's done a bit more analysis here, added an annotation too, and we've also got the year built as a kind of third element in this visualization, which I think adds something a little bit interesting. And the number of bedrooms, I don't know if you can see down here, but there's a legend for the number of bedrooms. So we can also see, as you would expect, when bedrooms are sort of 5, 6, we definitely see those higher prices. But there's a lot of overlap here between the 3s and the 4s. The 1 bedrooms, of course, much smaller, but yeah, 2, 3, and 4, quite a lot of overlap in the middle. And that's quite helpful to know. Similarly, if we turn our attention to the year built, we can see that certainly the older houses tend to be smaller, which does kind of make sense. But those older houses also span the lower and higher prices. So you couldn't just assume that an older house was going to be necessarily cheaper or necessarily more expensive. So there's definitely a lot of diversity there. And the last one on this case study, I believe, is just looking at the price by the year that the property was built. So line charts, super simple to understand. Maps are very intuitive, scatter plots are very intuitive, but I also really have a strong fondness for a time series chart. So where we've just got, along the bottom, we've got the year that the property was built. We've got a drop-down list here of the number of bedrooms, and we've just picked 3 and 4 just to focus on for now. And then we've got the average price that that property was sold for. So for properties that were built, you can kind of see it. I think it's an interesting trend here in the middle. For properties that were built in 1940 to, what should we say, 1941 to 1943. 1941 to 1943, there was a real drop in the property prices. Now, this is in Seattle, but maybe some of you can already guess what was happening at that time in Seattle. And if you haven't come to that conclusion already, that's fine. But what I think is happening is there's a shortage of materials during the Second World War. So maybe things were being made with slightly cheaper materials or less high quality, or made slightly quicker if there was a shortage of housing or a shortage of labor, because of the impact on America of the Second World War during this moment. So what we do know is that there is a sort of interwar period where the prices are slightly lower. And to make our model more accurate, more efficient, we could create a new feature, a new column that says, is it in the interwar period? Was it built in those years between 1941 and 1945, 46? So just to give you an idea, these are the sorts of things that you can pull out from getting to know your data. And if you're looking at a brand new data set and you really don't know anything, my best advice would be to get into a tool like Tableau, which is super quick, very visual, and just start playing around with the variables and see what you find out. Similar to this, we can also visualize very easily things like feature importance or feature impact. So this data set is taking a number of features, only a small number, and looking at the impact that this has on the model in the model output. So taking a direct relationship between the features going in and the machine model predictions coming out. We can see which ones have higher feature value and lower feature value. So we're looking for the latitude, the longitude, and the median income definitely seem to have more impact than others. Now, I always get my students to do one of these types of visualizations. Maybe you've seen it before. It's called a correlation matrix. It's using a Pearson's correlation model to discover the relationship between all of the features in my data set. Now, this is the very, very first case study that we work on in class. And what we have here is a diverging color palette. This is actually one that I did just on Thursday of last week, when I was introducing the students to this data set. And we were looking at relationships between all of our features and the column that we were going to predict, which is actually this one, the target D, the target donation column. And what this case study is about is a lot of donors to a marketing fundraising campaign for a not-for-profit. And so we take all of the information we have about them. They're named a bit strange. You have to forgive me on this, but average gift, for example, is the amount that they have given in the past, the same donor. Per capita income is in here. And then we have a lot of census information about where they live as an indicator of wealth. And we also have the date of birth of the donor and a few other things. Not that much information, but we're looking just at the numerical features here. We have other features that are not numerical. And we're looking to see which of them has the greatest impact on the target donation, the column that we're going to predict. And without too much trouble, because this is colored, you can kind of already see that the one that has the highest relationship, probably it's a little bit intuitive without having to do the analysis, but you can see it working here, is we have a good solid relationship between the average gift, so the average that somebody has given before, and the target gift, the donation we're expecting this time. This is a correlation matrix. As I said, I have my students do one pretty much every time they look at a new data set. And this is in Python. The previous visualizations I showed you were in Tableau. So I've got the code up here so you can see the kind of code that we're running to configure that. It's a heat map, specifically over a correlation matrix. We've masked it. If you're wondering what that is, that just means I've dropped out the upper half of this matrix so I don't have any repetition. Center, that's the center of the color range, is at 0, which reflects down here. The color map is based on a diverging palette, which I've determined in here. And then annotate equals true means I've included the labels for the numbers. So just thought I would explain that in case anyone was wondering what all this code was on the top if they've not seen Python before. You set up the chart and then you plug in your variables, what you want to see. Now, unfortunately, pictures are not always that helpful. So I thought, obviously, I've showed you some great examples of where we can use images to help explain things and make things easier, more accessible, and demystify concepts, but sometimes it doesn't work. Some data science concepts and models are actually not that easy to explain through pictures, and some, I mean, I've been teaching this course for a year and a half now, and I'm still struggling to find the best pictures to explain these things or the best diagrams. So a couple of examples. Now, I showed you the linear regression model before, which people are always pretty good at understanding, a nice straight line on the X and the Y axis. Every time I bring this image up, particularly with the very the very off-putting formulas in here, the students get upset. So how do you explain a logistical regression model if they've understood a linear regression model, which was super straightforward? Now we have to try and explain something a little bit different. Logistical regression, we don't have a number of continuous values between the intersect or the base point and the infinite value of y. We just have two values. We either have zeros or ones. And that's because logistic regression is used for classifying things, for picking out A's and B's, trues and falses, ones and zeros. And in this case, yeah, it's going to be a true, false, or an A-B type logistical regression problem. People get a bit uncomfortable when I draw this S-curve on the screen. The easiest way, I think, to explain logistical regression is actually to draw an S-curve over the top of lots of individual points, as you can see here. So in this case, very clearly, we've got the boundary between the reds and the blues. We've got the false samples, those are the reds, and we've got the true samples, those are the blues. We still have it on an X and Y, so it feels kind of familiar. It's not super accurate, I would say, in terms of what it's doing, but it does allow me to draw attention to the fact that there's a few escapees. You can see a few of the red dots are just scooting over the boundary line there, and explains in a nice, easy way that sometimes some points are misclassified using this model. Another example is when we're trying to explain K and N, K nearest neighbors, or the K-means algorithm. And again, if I draw that on an X and Y plot, people get a bit uncomfortable. They're wondering about what these circles are, these intersecting circles. And I've always found this image is a little bit hard to get across to people, requires just a bit more explanation. It's not very intuitive. And again, sometimes what might be easier is, although this looks very confusing and kind of trippy, actually what might be easier is to draw the points all out and then to try to draw the boundaries around them, as we've got here. Having said that, I don't find images that useful to explain K and N. I actually just find real life examples much easier. And we do a great project in my course in week 7, where we use a K-means unsupervised algorithm to cluster music from Spotify that we've accessed via the Spotify API, the Spotify API through a connector type, Spotify, designed for Python. We collect a load of songs. We ask the user or ask the customer, let's say, to put in the types of songs they're interested in, the types of music they're interested in, and then using a clustering, an unsupervised algorithm, K-means algorithm, we will cluster and recommend back to them another song from that cluster. So the idea is a bit like the way that the Spotify algorithm works. We build something kind of like that based on our own collection of songs. Similarly, decision trees are really easy to understand because I think this is quite intuitive. This is an example from the Titanic dataset, which is quite a well-known classification problem that we would see in beginning intro to data science classes. So this is if we got everyone on board the Titanic, we found out all the information about them, which class they were in, first class, second class, third class, were they male, were they female, what are the chances of them dying and surviving? So decision trees are really easy to explain using pictures, using diagrams. Random forests, which is a model that uses multiple decision trees, often raises a few questions in the class. We'll see a few people saying, "Yeah, understood the decision tree. Now you've presented me a forest of trees, and I'm confused as to what's happening." So that does require a little bit more explanation. I can't just pull up a quick image and expect everyone to understand it. But once you do understand it, you can then return to a nice simple visualization, a nice simple bar chart like this. So once you get your head around not just one tree, but multiple trees, and then the aggregate prediction of all of those trees, the best or the worst or the average, then we can do something like random forest feature importance analysis, where we work out which of the hundreds or dozens of features in a data set have a huge impact on the result. And just one last meme for you, because I couldn't go away without showing it. I sometimes use images such as this to explain why machine learning is not always brilliant at the job that we give it. And this is, for example, an image recognition. Image recognition or image classification project where you you ask the machine learning algorithm to identify the difference between which images are chihuahuas and which images are chocolate chip muffins or blueberry muffins. And as you can see, it's difficult for our eyes. It's certainly difficult for a machine, for a computer. So that's my last meme, I think, for today. But I hope you like it. It's one of my favorite. Okay, so in summary, when you're trying to explain to your team or to your client what you found with the data, so what your insights were about the data, and you're trying to just talk them through those processes that you took, or maybe you're thinking to yourself, um, how am I going to communicate what I've done afterwards once I'm working on all these very complicated processes? I hope you'll think about using more imagery, more pictures, more diagrams to help them understand some of the things that I've talked about today. I hope that will be useful for you in your future summaries and explanations. And that's it from me. Thank you very much for attending. I think I'm about 2 minutes under time, so I hope that's not a big problem. I've just put my contact information up on the screen there. So if you want to contact me, I'm sian.davies@ironhack.com. I'm in Barcelona. Our campus is in Poblenou. We would love to see you. Pop in anytime. At the moment, we're all teaching in person, and hopefully we'll stay that way as long as we can keep the pandemic cases out of out of the building. And you'll also find me on LinkedIn. So using my full name, Sian Elizabeth Davies, on LinkedIn. And that's all I have. I believe there might be some questions.
Yes, Sian, thank you very much for this talk. It has been really interesting. Indeed, before the questions, I would like to share that I think that it's some of your students connected because they have wrote on the chat, "Hello, I am a Sian student." So just for you to know that you have some students connected. And
nice.
I will go for the
Hi,
first.
guys.
I will go for the first question. Are there specific techniques about how to show the information in image efficiently?
Yes, there are specific techniques. We teach one of the days we do a data visualization best practice, and there's some really core principles for that. One of the core principles is not overwhelming the person that you're speaking to. And that's because cognitive processing is hard work. So if you're trying to communicate visually to somebody, especially if it's quite a complicated concept that you're trying to communicate visually, you ideally want that person to only be processing maybe 2, maximum 3 things at once. So what you would focus on would be color, which is a pre-attentive attribute, and using color quite carefully and cautiously. So I often recommend things like using one highlight color to sort of and show and make it really clear what you're trying to draw the attention to, and then grade everything down in a sort of gray or a darker color. And I would also suggest using size, because people intuitively understand size. So showing something's bigger or smaller based on the size of the visualization. A bar chart is a typical example for that. And then the third thing would just be using something quite simple that people can intuitively understand. Scatter plots, bar charts, line charts. They're always good go-tos. If it's geographical, put it on a map. People understand maps. They're used to maps. So make the most of what people already know would be my tip around that.
Okay. There is another question that it's maybe linked to that. Is
Sure.
it difficult for you to translate information into images?
Yes, sometimes. So in those examples I showed towards the end, where I'm dealing with models which don't translate very well to images, or if I'm trying to explain something that maybe isn't familiar to us. So we have a case study that maybe something none of us have ever really encountered. In fact, that first case study that I have in my class is a fundraising case study for a marketing model, a fundraising model that I have never encountered before. And I think that makes it hard. But then on the other hand, I find that people's understanding of imagery and diagrams and processes left to right with arrows and simplified images that you can draw in the middle, it really helps fill in that gap. And that's part of, I guess, being a teacher is learning all those tricks, learning all those let's say useful and easy ways, accessible ways to explain those kind of concepts. But yeah, sometimes even for me, I look at something and go, "Oh, I don't really know how I'm going to explain that statistical method or approach in a visual form." It can be really difficult.
Okay. There is another question. How it has been to pass from the consultancy sector as Deloitte to becoming a teacher or a lecturer?
Well, I've been very lucky in that regard. I was a consultant before the pandemic, and so one of the things I really grew to kind of not like about my previous consulting job was that I was constantly packing a suitcase, and I was constantly getting ready to travel somewhere, stay in a hotel, not always a very nice hotel, go to a conference suite, go to a building, that kind of thing. And what I love about switching to teaching is that I get to basically stay still. The thing that I do miss, though, is that constant challenge that you have from different industries, from different methodologies, from working with teams that maybe have existing architectural requirements that you have to fit into and work around. And I miss that sort of daily challenge, but then I have different challenges from students instead. It's definitely been a transition. There's things I miss, but there's certainly things I don't miss, like packing my bag all the time and traveling.
There's another question that I think it's directly related to your answer.
Sure.
What do you enjoy the most of being a teacher?
That's a great question. I think what I enjoy the most is when I have a student come into the room who thinks, for whatever reason, on whatever day, on that day, or in that week, or maybe at the start of the class, that I'm not going to get this. I'm not ready for this. I don't know enough. I can't get my head around this thing. It's too difficult for me. And I love being able to turn that thought around. I love being able to see them at the end of the day or the end of the week or the end of the class, maybe come to me at the end, or come to the graduation day, come to the final presentation, and they're doing something that they didn't think they could do just a few weeks ago. And we see that time after time, and it's such a joy because it really does invert somebody's understanding of their own limitations. And that's my favorite thing about teaching, is being able to help them do that.
Okay, great. And I think we will abort now the last question, which is what data visualization will be in 20 years?
Oh, that's a tricky question. What data visualizations will be in 20 years? I mean, I think if I'm honest, I see a great future for virtual reality and augmented reality with data visualizations. I see us getting to a point where you can walk into the middle of your visualization and sort of move things around yourself. We're already starting to see a little bit of that. But I think that's the real piece that's missing now. It's not about having a different chart type or a different graph or a different graphic. I think it's about allowing you to go inside and be able to explore from the inside rather than feeling like you're on the outside. So I think that's going to be the change that's coming. And that's something I'm excited to see.
Okay, thank you very much, Sian. You have answered already the last question.
Great.
I would like to thank you very much for your participation and for such an interesting talk. I hope to see you soon, and well,
Yes, absolutely.
Thanks again for participating in the International FemHack. Thanks for your time.
Thank you so much, everyone, to the organizers, and thank you to the audience. Thanks for joining me today, and I hope we've all learned something.